Hello guys, welcome back. In today's video, we will draw shear force and bending moment diagram for this simply supported beam. As we see here, there are two supports. This one is pin and this one is roller. There are 2 point loads, 50 kN each. So how do we start? First, we draw free body diagram for this beam. And here as we see, there are two reactions coming from the pin support and one reaction here coming from the roller. Now we need to see if this beam is statically determinate or not. To know that, we count the reactions we have. Here there are 3 reactions. And then count the equations you have. There are 3 equations. Sigma fx equals to 0, sigma fy equals to 0, and summation of moment equals to 0. Since E equal to R, so it's a statically determinate structure. Now let's calculate reactions of the support. Since here there is only one reaction on the x-axis, Ax equals to 0. Now for the y-axis, there are 2 unknowns. We can't solve them by sigma fy equals to 0. We need to take the moment about some point. I will take the moment about A. Summation of moment about A equals to 0, and I will take positive clockwise. Now all the forces rotating clockwise is positive. 50 by 10 and plus 50 by 20, then minus by by 30. Minus because by is rotating counterclockwise. So solving this will give us by equals to 50. Let's calculate Ay by sigma fy equals to 0. So we have Ay minus 50 and plus the reaction, which is 50, equals to 0. So Ay equals to 50 kilonewton. Maybe some of you noticed that this is a symmetric beam. So from the very beginning, you will know that the reactions will have the same values. Now let's draw the shear force diagram. There is 50 kilonewton here, positive. So we go up, starting from this point, by 50 kilonewton. Nothing is changing here. We go the 0 slope, straight line. Here there is 50 kilonewton, minus, so we go down. Here nothing is changing. We go straight line. Here there is minus 50, so we go down by 50. Nothing is changing here. 0 slope. And there is plus 50, we go up 50. So this value here is minus 50 kilonewton. Now to draw the bending moment diagram, we need to calculate the area under the shear. Here we have plus 50 kilonewton, and this distance is 10. So this is plus 500 kilonewton meter. And here there is minus 50, and this distance is 10. So this is minus 500 kilonewton meter. Now we are ready to draw the bending moment diagram. When you see here a positive sign and a rectangle, so you need to know that you will go up with a slope by 500 kilonewton meter. Now straight line here, straight line here, minus 500 and a rectangle, so slope downward, and finally the value here is 0. Shear force diagram and bending moment diagram have to close at 0. If they don't, revise your calculations. Now if you are required to specify how much the maximum moment, simply Mmax is equal to positive 5 kilonewton meter. Thanks for watching. See you next videos.